All right, so we have this function g of x equals 6 times x to the negative 3, and we have to answer these following questions. So I noticed that the x has an exponent with negative, so I can rewrite this as c over x to the third. So if the exponent is negative, I can move it down with positive exponent. So then, again, I'll rewrite it here, g of x equals 6 over x cubed. Now, if x doubles, so if the input is not just x, if the input is 2x, so now I'm looking at the function g with the input being twice x, so 2x. So let's calculate what g of 2x would be like. So this is going to be 6 over, instead of x, I have 2x now, so this is going to be 2x to the third power. And then the goal is to calculate this and spot a g of x. So let's see what I mean by that. So I'm going to say this is 6 over, I can distribute the exponent. This is just rule of exponents. So this is going to be 2 to the third times x to the third. So notice that if I just look at this portion, 6 over x cubed, that's actually g of x. So I can rewrite this as g of x over 2 to the third, right? Because this portion right here is all g of x. So this is the same as 1 over 2 to the third is 8 times g of x. So clearly, when I double the input, the output is not going to be double what it was before when the input was just x. It looks like it is multiplied by a factor of 1/8. So when x doubles, the value of g of x is multiplied by a factor of 1/8. So you have to be careful. If x doubles, that doesn't mean the output also doubles. Okay? So now similarly, if x triples, the value of g of x is going to be multiplied by a factor of what? So now I'm looking at the input triples. So instead of x, I have 3 times that. So then this is going to be 6 over the input now is not just x, is 3x. So 3x. So similarly, the goal is to rewrite this so that I have g of x. So I'm going to distribute the exponent, so 3 to the third times x to the third. So do not reduce this. See, we didn't reduce the 6 and the 8 in here. The goal is to keep g of x intact. So this is the same as 1 over 3 to the third times g of x. And 3 to the third is 27, so 1 over 27 times g of x. So when the input tripled, the output was multiplied by 1 over 27. So that's what you would put in here. So if the input triples, the output doesn't triple as well. It's actually divided by 27 because there is an inverse relationship between the input and the output. So the goal is to rewrite this but keep g of x. And then you notice what's the difference between this one and that one? Well, that one is multiplied by 1 over 8. I mean, the difference between that one and that one when I doubled the input. Hope this helps.